Hi, I'm Shri. Welcome to my channel. In today's video, I'll talk about how RAG, short for Retrieval Augmented Generation systems work, and how the Search My Docs overall architecture is built. If you are a student like me who is on a learning journey in the field of artificial intelligence, machine learning, and deep learning, you might find it helpful. But if you are an expert and you already know what RAG systems are, you might appreciate the perspective of a beginner student who is just starting his journey. In this video, we'll cover what RAG technique is and how Search My Docs uses this RAG technique to retrieve critical information from the documents. So what is a retrieval augmented generation? A 35,000 feet overview definition is it's basically an information retrieval technique. So you have a bunch of data and you want some information you're looking for. So you can use RAG technique to get that information. So that's a high level overview. Let me explain it with an example. So let's say you're planning a trip and you have a bunch of documents. You have reservations, you have your travel itinerary and all those stuff, and everything is in a folder. And now you're interested in specific information, for example, a reservation ID. But you don't want to scan through all the files and figure out where it is. It is cumbersome, it takes more effort. You just basically want to ask something to give that information and get it instantaneously. You basically use a technique called Retrieval Augmented Generation to get you the exact answer you want from your document collection. So taking a little bit deeper view, this technique combines two different models. One is the retriever model and the other one is the generation model. The responsibility of the retrieval model is to select those pieces of information from your document collection which are relevant to your query. For example, there could be a lot of information in your travel folder. There could be like a packing list, there could be a travel itinerary, there could be the ticket information. So when the query is about tickets, the responsibility of the retriever model is to extract the information that is relevant to the query. So once the information is retrieved, the generator model kicks in. So the responsibility of generator model is to take your query, take the information returned by the retriever model, put that all and submit it to LLM, and let LLM decide the response based on the information and the query. So by combining these two models, you can use RAG technique to retrieve critical information from a large document collection. Now that we have looked into basics of retrieval augmented generation technique, let's look into the overall architecture of how a question answer system or a chat with your document collection works. So we got a good overview of the retrieval component and the generation component. So let's dive deeper. So before you query your document collection, you have to figure out where you're going to store them. So this can be any cloud object storage service like S3 or Azure or Cloudflare's R2. So once your files are uploaded to a cloud storage service, the next step is to process them. So consider this example, you have uploaded a PDF file to one of the storage services. So once your PDF has been uploaded to a storage service, the next step in the process is semantic chunking. In semantic chunking, we break down the file into smaller logical chunks. These chunks are not arbitrary. We are not cutting the files at some arbitrary text length. So instead of splitting the text arbitrarily, we will try to break down the file into logical chunks such that their context is still preserved. Consider this example. You're planning to go on a trip to Hawaii and you have a file which has all the activities you're planning to do while you're in Hawaii. So one of the activities is cage diving with sharks and the other activity is a hike in the jungle, and these activities are in their own paragraphs. So in semantic chunking process, when you give this travel activities document as the input, the goal is to break the document down into two chunks. One chunk talks about cage diving with sharks and the other chunk talks about hike in the jungle. So now you have split the document into chunks, but you have still retained the context in each chunk independently. The next step in the process is embeddings. The oversimplified explanation of embeddings is it is a process of converting a chunk of text into array of floating point numbers, and there are different embedding models we can use to convert them to floating point numbers. So these floating point numbers are basically a representation of the semantic chunks, and the chunks and their embeddings are stored together in a vector database. This can be Postgres with a PG vector extension, or this could also be a dedicated vector database such as Pinecone. To recap, this is what we covered so far. Once the file is uploaded to cloud storage, we break it down into semantic chunks, and these chunks are converted into embeddings, and they are stored in a vector database along with their chunks. Here we have completed the processing part of the document collection. So in the next step, we are ready to handle the queries. So when you query your document collection, the text you use to query is converted to its vector representation using the same embedding model that we used earlier for processing our document collection. So now we have a query embedding, and then we have a lot of embeddings from our document collection, and we have to do a similarity match of which of those embeddings from our document collection matches closely to our query embedding. So there are different similarity search algorithms. One of the similarity search algorithms we can use is cosine similarity. So a cosine similarity score of 1 means there is high degree of similarity. So let's say we have submitted a query, and the query was converted to embedding. So we try to match with cosine similarity with the embeddings we have from our document collection, and some of the embeddings were a match. Let's say out of 10 chunks, 10 embeddings, 3 of them had a cosine similarity score of greater than 0.9. So while doing the similarity settings, we will set a threshold of 0.9. That means consider all embeddings in the result whose cosine similarity is greater than 0.9. So once the query runs, we can get the actual chunks as the result. So we take this query and we take the content returned by the similarity search and we submit it to LLM. So LLM looks at the query, looks at the content, and so the LLM looks at the query and the related chunks and hopefully comes back with an answer that is asked by the query. So this is the overall workflow of how a retrieval augmented generation system works.